what we just concluded was two plane mirrors perpendicular to each other, and we saw that if there was a point object, then there were three images formed. Four images, out of which two were coincident. Now what we are going to do is we are going to embark on the mission where we will not take the two mirrors perpendicular to each other, but inclined at a certain angle theta. This is mirror M1, this is mirror M2, and they are inclined at an angle theta, and there is an object placed between the two mirrors, and the line joining the point of intersection of the mirror with the object makes an angle alpha with one of the mirrors and makes an angle beta with the other mirror. This is the situation that we are going to explore and hash out. We'll make life really simple for you. Alright? So first things first, a few basic simple observations before we get on to the actual stuff. So suppose this was a plane mirror M. This was a plane mirror M, right? And there was an object O placed at a distance x from this plane mirror. And there was P was any point on the plane mirror. P was any point on the plane mirror. Alright. Now, if O is the object, I would be its image, and object distance x is going to be image distance x. Yes or no? Right. Now I join P to O and I join P to I, the image of O. Notice then a few very basic things. This triangle, let me call this point D for example. Triangle OPD would be congruent to triangle IPD. Triangle OPD would be congruent to triangle IPD. Why? Because see, PD is common, OD is DI is x, object distance is image distance, and this angle is 90 degrees. 90 degrees. So from SAS condition, the two triangles are congruent. Now if the two triangles are congruent, very clearly OP will be equal to PI. OP will be equal to PI. OP would be PI. Yes or no? Right? Also notice that if angle OPD is alpha, angle DPI will also be alpha. These two angles will be equal. Congruent parts of, corresponding parts of congruent triangles, right? So the line joining P to O and P to I will be equally inclined with the mirror. Line joining the point P to the object and the point P to the image would be equally inclined with the mirror. So with P as the center, and OP or PI as the radius, I could have drawn a circle passing through O and I. Yes or no? With P as the center, that means O and I both lie on the same circle. The object and its image both lie on the same circle with center as P, where P could be any point on this mirror. Yes or no? Now, having understood this, let me get down to this situation, which is our primary intent. There is a mirror M1 and there is a mirror M2, right? And they're inclined at an angle theta with each other. And there is an object O. And I take the point of intersection of the two mirrors as P. Now I join O to P, the object to the point of intersection, right? And suppose that makes an angle alpha with the plane mirror M1, and that makes an angle, OP makes an angle beta with the plane mirror M2. Now I want to be able to geometrically locate the images. So first things first, do you realize that the object and the image will lie on a circle centered at P, on the same circle centered at P? That means if P is any point on this mirror and if O is an object, then with PO as the radius, if I draw a circle, then all images will lie on that very circle. With P as the center and PO as the radius, if I draw a circle, then the images will all lie on this circle. Yes or no? That's exactly what I mean. You know, this, an extension of this idea, right? So first of all, whether it's M1 or it's M2, if I join O and P and if I draw a circle centered at P and radius OP, then all images, whether they're formed by M1 or by M2, will lie on this very circle, right? So images would be concyclic points. Now, let's start locating a few few of the images. So let me look at M1, right? O is the object and O1 is its image formed by M1. First image, first reflection on M1, first reflection on M1. O is the object, O1 is its image formed by M1, very clearly from the principle that I just illustrated. If OP makes an angle alpha with M1, then PO1, where O1 is the image of O, will also make an angle alpha with the mirror, right? So which means if this angle is alpha, this will also be alpha. This is the first image formed by M1, first reflection by M1, first reflection by M1, this is the image, right? Similarly, look at M2. If O is the object, then O2 is the image formed by M2, first reflection by M2, first reflection by M2, right? And if this angle is beta, then this will also be beta. If the mirror makes an angle beta with OP, then the mirror will make an angle beta with PO2, where O2 is the image of O. Yes or no? Now, first of all, what we'll try and do is, in order that our algebra is, the algebra is not complicated, we will measure angles from the two mirrors. We'll measure the angles from the two mirrors. So, let me call mirror M1 and mirror M2, and let's start locating their respective images. So, first thing first. The first image formed by M1, first reflection, is alpha from M1. Alpha is the angle made with M1 of the first image, right? The first image formed by M2, that makes an angle beta with M2. So the first images formed out of first reflection from M1 and from M2 separately designated alpha and beta, right? Now, notice that O1 is an object. For reflection by mirror on M2. O1 is image of O. O1 is image of O formed by M1, but serves as a virtual object for reflection by M2. Serves as a virtual object for reflection by M2. Yes or no? Right? So now, when it comes to M2, look at this M2 separately. Look at this M2 separately. Look at this M2 separately. Right here. O1 is an object. O1 is an object. So I'm talking of O1 acting as a virtual object for reflection by M2. Now I'm talking of O1 acting as a virtual object for reflection by M2. So this is O1. And its location makes an angle theta plus alpha with M2. Theta plus alpha with M2. Very clearly, its image formed by M2 would be O1 prime. That will make an angle theta plus alpha with M2. Yes or no? So then, the next image of M2, the next image formed out of second reflection by M2, right? This is O2 was first reflection by M2, now second reflection by M2 makes an angle alpha plus theta with M2, right? This is the image formed by M2 out of first reflection from M2. This is the image from M2 formed out of second reflection from M2, and that makes an angle alpha plus theta with M2. Yes or no? Right? Now similarly, look at this object O2, which is the image formed by M2, out of first reflection by M2. Yes or no? Now this image can act as a virtual object for M1. This image can act as a virtual object for M1. And see, O2 is the image of O, formed by M2, right? And very clearly it makes an angle beta with M2, right? From the geometry that we've just investigated. Now this image formed by M2, first reflection from M2, acts as a virtual object for M1 and would be the image formed out of second reflection from M1. So then if this is an object for M1, then this angle would be theta plus beta. This would be theta plus beta, right? This angle is going to be theta plus beta. So M1 will then form its next image formed out of its second reflection, formed out of second reflection, which is like theta plus beta from here, so theta plus beta from here, right? Theta plus beta, which is the second image. Yes or no? So what has happened? We've arrived at a rule. So all that you need to do is you need to understand this rule. What is the rule? So at angles alpha and beta, I'm able to locate first image formed by M1 and M2, reflection from M1, reflection from M2, right? When it comes to the next image, formed by M1 and M2, then what we do is, to this beta, I add theta. That will be the next image formed by M1. That means second reflection from M1. And to get the next image from M2, what I do is, I add theta to this, angle, and I get the image out of second reflection from M2. Yes or no? So I add theta to this, I get the next image formed by M2. I add theta to this, I get the next image formed by M1. Now, to get the subsequent images formed by M1 and M2, I'm going to follow the same sequence. What am I going to do? I'm going to add theta to this. That makes it beta plus 2 theta. These are angles made with M2. These are angles made with M1. So I'm going to add theta to this. So that's going to make it beta plus 2 theta. That's going to be the next image formed by M2, right? Third reflection from M2. And I'm going to add theta to this, which makes it alpha plus 2 theta. That's the next image. Third reflection from M1. And then I keep following the sequence. Alpha plus 3 theta, beta plus 3 theta, beta plus 4 theta, alpha plus 4 theta, and so on and so forth. I can keep going on and on and on. Forever? Maybe not. So this is the sequence of images formed by M1 and M2, and these are angles made with mirrors M1. These are angles made with mirror M2, right? So that's a sequence you have to understand. That's really the sequence that one needs to understand. For M1, so every time you have to go from a pair of images of M1 and M2, add theta to this, you will get the next image formed by M2. Add theta to this, you get the next image formed by M1. Add theta to this, you get the next image formed by M2. Add theta to this, you get the next image formed by M1. So I have a sequence of images at my service, at my disposal. Yes or no, right? This is how it happens. This is the way it takes place. Yes or no, right? So once we understand this, we can now get on to the task of figuring out how many images eventually would be produced. I can figure out how many images that could actually be produced. What I'll do is, I'll take actual numbers and arrive at an answer, right? I'll actually take a certain angle theta, a certain angle alpha, a certain angle beta, and tell you how many images eventually you could have had. Alright, thank you so much. I get on to the next part of the same discussion, where I would draw very important inferences and conclusion in terms of the number of images that could be formed. Thank you so much. Bye. What we have taken cognizance of is the sequence of images formed when mirrors are inclined at an angle theta, right? So here's a situation where we have two plane mirrors M1 and M2 inclined at an angle theta equal to 60 degrees. And there is an object O, which is placed 30 degrees with M1 and 30 degrees with M2. And I want to be able to find the number of images. Theta is 60 degrees. Like I said, you know, if you've seen my previous session, part A of this discussion, then you would know how to locate the images with respect to M1 and M2, right? So the first image formed by M1 is O1, making an angle 30 degrees with M1. The first image, first reflection by M2, this is O2, 30 degrees with M2, right? 30 degrees with M1 and 30 degrees with M2 are O1 and O2, images formed out of first reflection from M1 and M2. How do I locate the subsequent images? As simple as this. So I add 60 degrees to this, I get 90 degrees from M1, the next image, second reflection from M1. I add 60 degrees to this, I get 90 degrees from M2, second reflection from M2. And then I add 60 degrees to this, 150 degrees, 150 degrees. And I add another 60 degrees to this. I get the next image from M2, 150 degrees. Right? That means now what has really happened is, look, this is 60 degrees. This was the mirror M1, this was the mirror M2, right? And then eventually I had, as seen by M1, 30 degrees, 90 degrees, 150 degrees, right? So there is an image like 30 degrees from M1, and there is an image like 90 degrees from M1. That's another image. And then there is an image like 150 degrees from M1. So 90 plus another 60. So that comes down here. 150 degrees from M1, 150 degrees from M1 would be this. 150 degrees from M1 would be somewhere this. That would be one image, right? Set of images, 150 degrees from M1, right? Look at images formed by M2. So there is 30 degrees from M2, which is this, right? And there is 90 degrees with respect to M2, which is the next image, 90 degrees. And then there is another 150 degrees. So this is 90 degrees, and then there is another 150 degrees. You'll realize it'll just come down here. It'll just come down here, right? So I have essentially 1, 2, 1, 2, 3. As far as M1 is concerned, as far as M2 is concerned, 1, 2, and 3. Realize their third images coincide. Their third images coincide. That means essentially, what do I have? 1, 2, 3, 4, right? 1, 2, 3, 4, and the next image, next two images, one formed by M1, the other formed by M2, are coincident images. Why? Because see, if you again check this out, so this was angle theta equal to 60 degrees, and this is 150 degrees from M1. So sorry, this is 150 degrees from M2. There is 150 degrees from M1. The last images, 150 degrees from M2 and 150 degrees from M1. And look at this theta. Theta is 60 degrees. That means these last images, so 150 plus 150 plus 60, 150 plus 150 plus 60, that makes it 360 degrees. And that's the reason, see, this plus this plus this. If these two angles, if the last image is formed by the two, and why can't I form more images out of these? That is important to understand. I mean, in the sense, I could have added 60 more degrees to this, 60 degrees, and I could have added 60 more degrees to this. So that makes it 210 and 210. And realize that, you know, if I move from M1, eventually 210 degrees, I'll go behind M2. Realize that if this is 150 degrees, Look at M1, 150 degrees. 150 degrees is this position for M1. This is 150 degrees. And if I add another 60 degrees, I'll go down here. So then what would happen is I'll go behind M2. Look at 150 degrees from M2. 150 degrees from M2 is this, right? And then I go another 60 degrees. I go another 60 degrees like this. I'll go behind M1, right? So the moment these angles are within 180 degrees, less than 180 degrees, I can keep adding theta and obtain the series of images. The moment any one of these angles become 180 or more, I have to stop there. The moment any one of these angles becomes 180 or more, I have to stop there. So in this case, I have to stop here because adding more to this will become more than 180, 210, this will become more than 180. So even if one becomes 180 or more, I have to stop, because then the subsequent images would be behind the mirrors, and then no image can be formed, right? In fact, this is the cone beyond which, if the final image is I and I prime, in this case 3 and 3, if they lie in this cone, then beyond this, if you add theta subsequent to this, then the next images will go behind the mirrors, and that cannot happen. So eventually, you have to stay within 180 degrees. Less than 180 degrees, you have to keep doing this process till the time it is less than 180. It becomes 180 or more, you have to stop there. You can't keep adding images all the time. So you perform this operation only as long as any one of these angles is becomes 180 or more, right? So as long as these angles are less than 180, it's good. The moment any one of these angles becomes 180 or more, you have to stop and stall the process and begin the process of counting. In this case, 1, 2, 3, 4, 5, 6. But the last two images coincide, so it's not 6, it's 5 images formed. Yes or no? 5 images formed, right? Let me take another case. So these were two mirrors, M1 and M2, and there was an object O that was symmetrically placed between these two, and that's how we computed the number of images. Let me look at a situation like this. Let me look at something like, say this was mirror M1 and this was mirror M2. This was the point P, and say the angle between the mirrors was, say, 70 degrees, and say this angle was 30 degrees and this was 40 degrees, and I want to count the number of images. I want to be able to count the number of images. What do I do? All right, so M1, M2, angle theta is 70 degrees here. So first one, 30 from here and 40 from M2. So the first set of images 30 and 40 from M1 and M2, and then I keep adding 70 degrees. So I add 70 to this, I get 110. I add 70 to this, I get 100. Then I add 70 to this, I get 170. And then I add 70 to this, I get 180. 180, of course, I have to exclude. This will not be an image, right? So eventually, how many images? 1, 2, 3, 4, 5. And I can't add another 70 to this because this is going to exceed 180 degrees. I have to stall the process at this point. So how many images? 1, 2, 3, 4, 5. 5 images formed. 5 images formed, right? 5 images formed in this case. Let me take another case. Say I have two mirrors at an angle theta equal to 30 degrees, and say this angle is 10 degrees and this angle is 20 degrees. This mirror is M1, this mirror is M2, and this is the object. So now, let me mark M1 and M2. The first image from M1, 10 degrees, M2, 20 degrees on that side, and then I keep adding how much? 30 degrees. I keep adding 30 degrees. So I add 30 to this, I get 50. I add 30 to this, I get 40. Then I add 30 to this, I get 70. I add 30 to this, I get 80. Then I add 30 to this, I get 110. Then I add 30 to this, I get 100. Then I add 30 to this, I get 140. Then I add 30 to this, I get 130. And then I add 30 to this, I get 160. I add 30 to this, I get 170. And I can't add any further. Right? Because if I add 30 more, these angles will exceed 180 degrees. So I'll have to stall the process. Now, to figure out whether the last images coincide or are different, I need to add these angles to theta. So if I add 170 plus 160 plus 30, hey, does it turn out to be 360? See, this is 330 plus 30, 360. Oh yes. And therefore, these two images coincide. So these two would be counted as one. So how many images? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 1, 2, 3, 4, 5, 5 and 5, 10, and 1, 11. 11 images, therefore. 11 images, because the last images coincide. That is what happens. Do you all understand whatever I have said here? So this is what you do. This is what you do when mirrors are inclined at an angle theta, right? And of course, you know, books would have presented to you umpteen formulas, 360 by theta and 360 by theta minus 1, various cases. 360 by theta even, 360 by theta odd, but realize that's incomplete, because you know 360 by theta need not be an integer. So if you understand this, then you know you'll be able to deal with any situation where you encounter mirrors inclined at an angle. Yes or no? Thank you so much. Bye bye.